How to calculate expected returns for a security. To calculate the expected return for a security based on discrete statistics, you multiply the probability of each possible return scenario by its corresponding return value. Then you add all those products. So what it turns out is expected return equals probability of outcome 1 times the potential return for that outcome. Then you add to that the probability of outcome 2 times the potential return 2 plus the probability of outcome n times the potential return n, and you do that for all the data sets that you have. Key points about calculating expected returns include discrete statistics. Again, this means you're considering a set of distinct, verifiable, observable, possible outcomes with their corresponding probabilities. We're not looking at a continuous distribution, we're looking at a few key numbers. Probability weighting, we have to take that into account as well. Each potential return is weighted by its probability of occurring, giving more importance to scenarios with higher likelihoods. An example might be, imagine an investment with the following potential outcomes. You have a 50% chance of a 20% return and a 50% chance of a negative 10% return. So 50-50, but you're looking at a 20% return versus a negative 10% return. So you'll take that 0.5 or 50%, multiply that by 0.2, figure out what your product is there, and then add to that 0.5 or 50% times 0.01, which would be the negative 10. So what you come up with is 0.05 or 5%. That means the expected return for this two sets of outcomes is 5% positive. Some important considerations. The accuracy of your expected return heavily depends on how well you estimate the probability of each potential outcome. You can seriously skew numbers if you don't have the probability of those outcomes determined. While expected return provides a potential average return, it does not capture the volatility or risk associated with that investment. To fully understand risk, we need to consider standard deviation, which we will get to. But right now, we're just trying to find that expected return.